Okay, this is 1.7, constant rate of change. Your homework today is page 69, 1 through 4. Okay, so go ahead and write the vocabulary down. This is a rate of change. So a rate of change is a rate that describes how one quantity changes in relation to another, usually expressed as a unit rate. Now, what does that mean? Well, let's just talk about pizzas, right? If I have one pizza, it costs $12, right? That would be the same for two pizzas, would cost a total of $24. So the rate is the same. So the rate of change here is $12, right, for one pizza. As this one, so the rate of change, maybe it's not constant. In this case, it is constant, but all right, so the constant rate of change is the rate of change in a linear relationship. Linear just means a line. So if you were to graph it, it would be a line, okay? So it just means that it's changing at the constant rate, okay? So for every one pizza, it's $12 for every, so then if I have two pizzas, I just keep on adding. So it's the same. It could not always be constant. All right. What does a constant change look like? Well, it's going to be a straight line. So if it was one pizza, right, for I'm going to just do $25, right, it would look like this. If it was 0 pizzas, it would be here. If it was 2 pizzas, it would be $50. 3 pizzas would be $75. So a constant rate is a straight line. Finding a constant rate of change. You need to be able to use both a table and a graph to find the constant rate of change. So there's just two things. So you have to figure out what the rate of change is from a table or from a graph. Okay, so let's find the rate of change here. So I have 30 over 290 miles. So I have 30 minutes is miles. So I have 30 minutes for 290 miles. Well, this is equal to 3 minutes for 29 miles. This would be your rate of change, okay? However, this is about 3 minutes, I'm going to estimate, which is 30 miles, okay? So then my constant rate of change would be for every minute, it would be 10 miles, okay? So all I did to get from here to here is I divided by 3. Divide by 3. Okay, and I just estimated the 29 to 30. Okay, if I look here to here, right, I have 60 minutes over 580 miles. And then that is equal to, I can divide by 10, so 6 over 58, right? And that is about 6 over 60, right? Which is 1 minute over 10 miles. So same thing. So my rate is about, so my rate of change is 10 miles per minute. Okay? And you can continue to look and see that they're all similar. Next one. So using this graph, we're going to find the constant rate of change in miles per hour while driving. So here I see that for 1 hour, I go 30 miles. Okay, so this is the hour, because that's your X, and then this is your miles. For 2 hours, I go 60 miles. Okay, So what do the points mean? Well, the points mean here, the 1, this is 1, this is 2, and this one's 3, right? So this is the hours. The first part, the X, is your hours, and your Y, which is your second one, is your miles, okay? So what's the rate? Well, it's going 30 miles in 1 hour, okay? Or you can say 30 miles per hour. And then we also shorten that to mph, okay? Okay, so let's look at this in a little bit more detail here. So if I look from here to here, the dots are a little bit off, but that's okay. This is 1 hour, right? This is one space here. And then from here to here, I have from 90 to 60. So that would be just 30 miles, okay? So this is my rate. I have the rise, which is 30 miles, over the run, or going sideways, which is 1 hour, okay? I could look from the very beginning to get to here. I could look all the way up here. It's a bigger triangle, right? So I have, how many is it up to here? So I have 90 miles. For how many hours? It's 3 hours, right? So this would be 3 hours. So this is the same thing. Even though it's a bigger triangle, they're the same slope. So I have 90 miles for 3 hours. How do I get from 1 hour to 3? Well, I multiply it by 3. Same thing. These are constants, right? So I multiply the top by 3, and I would get 90. Okay, so the rates are the same, or the slopes are the same. So that means that they are this equivalent ratios, and they are equal, and everything doesn't matter where it's changing, right? The rate is always going to be the same. Okay. All right, so for right now, I would like you to work on page 69, 1 through 4. And number 1 is you have time, and then you have distance. Okay, so you have 1, 2, 3, 4, and we're talking seconds here. And the distance here is 6, 12, 18, and 24. Okay, and I want to find the constant rate of change. Okay, so for here, I have 6, we're talking meters for 1 second, okay, which is equal to the same thing as 12 meters for 2 seconds, which is equal to 18 for 3 seconds, and 24 to 4 seconds. Okay, so how much is it? What's the rate of change? Well, let's go back to our unit rate. So it's 6 meters per second. Okay, number 2. So I have this table that's items. You should be writing down this too, and cost in dollars. So I have 2 items that cost $18, 4 items that cost $36, 6 items that cost 54, and 8 that cost 72. Okay, so I have 2 items that cost, so I have price. I want to figure out the price per item. So I have 18 for 20 equals 2. So I want to figure out what it costs for one item. So to get to here, I would divide by 2. So 18 divided by 2 is 9. So I have 9 items. Oops, sorry, $9 per item. Okay, this is number 3. You need to find the constant rate of change. Now remember, on a graph, it would be the rise over the run, okay? And then explain what the point 0, 0 means. And explain what the point 19 means. Okay, let's go on to your last problem.